Hi, welcome to another exciting edition of CG Shader programming. We left off with ScreenSpace Shaders last time. My name is Nate Nestler, and this is for Hyperactive Studios. Now, last time, like I said, we left off on ScreenSpace Shaders, but we only did the pre-coloring for the actual just regular color and a texture. Now, I talked about gradients and how it can be done a little bit, but let's look at actually implementing it and making it happen in actual 3D here. And now, mind you, this can also be done on any texture surface you want on the actual model too, not just in ScreenSpace. So that's something I definitely want to point out to you. But this is going to be an RGB gradient effect. So all I have to do is come here to Create, Effect, and come over here and choose CG. So next, select Empty and name it ScreenSpace Gradient RGB. So again, that is ScreenSpace Gradient RGB. Or you can say Color Gradient RGB. I don't know, whatever. Either one will work. Alright, and then just say Next and then Finish. You should have this. Now you want to come over to your texture one, because that'd be the closest thing I can think of to this. And this is still a pre-technique, and we'll do a post in the very next technique that we do, but this one's going to be a pre still. So copy and paste your texture one. The reason why I say the texture one is because, well, it already has UVs, so kind of has some of the stuff we're looking for here. So copy that and then paste it into your shader over here. Okay, we're done with that one. We don't need it anymore. Alright, you should have something pretty close to this. Now, mind you, name it here as such, and then date it, and so on and so forth. Put your name, blah, blah, blah. Now, so all this stuff is the same here. This doesn't change. So as you can see, none, scene, pre-process, color, technique, technique 0, all this stuff's the same. Same old, same old. This is going to change in the next shader we do, but in this shader it's the same still. And then we have our world view projection here. World view projection, set to none, great, so on and so forth. Very straightforward still. And then we'll have something new here. This is where we get into something a little interesting here with our annotations. I really need to copy and paste that artist controls text from the other one into this one. I'll do that here. So if you want to, from your previous shaders back when, if you want to copy and paste those nice comments for the artist controls in here, it'd probably be a good idea. I need to do that because it kind of doesn't break it up well without it, and it'll help keep things clear. Because this stuff right here, above here, is not artist controls, and this stuff down below is. But anyways, it's going to be a float 3 here. Screen lower right, because it's going to be a color here. Open lesson sign here, string UI name equals, in quotes, screen lower right here, close quotes, semicolon. Alright, and then we say string UI widget equals, in quotes, color, close quotes, semicolon. It's going to set the color, closing greater than sign equal to curly brace 1.0f, comma 0.0f, comma 0.0f, close curly brace, semicolon, and we're just going to give it some kind of color. You can put any color you want here. I just made this one red, but it really doesn't matter. You can really set to whatever it is you want it to be, quite frankly. So, whatever floats your boat. It's not picking up the right colors when I do it, so, for whatever reason. So I just set them to these colors here. So I know I set my defaults, but it's not reflecting that. It's because whatever I set my defaults to currently is just not popping up like that in the interface like it should, like it normally does. I don't know what's going on, but whatever. Sometimes I make one change on the min and the max, and it'll just update it, the control all of a sudden, it'll suddenly update properly. I don't know, some bug of some sort. I don't know what's happening. I don't know if it's within FX Composer or a conflict between the operating system and FX Composer. It's very possible. But regardless, it is causing a problem for making the colors update or values on my sliders. So, anyhow, now right here, so we did red, and let's do the next one. Float 3 here is a screen lower left here. We're going to do the lower left part of the screen. So this is the lower right. Let's do the lower left here. So it's a float 3 here for this. Open less than sign here. String UI name equals, in quotes, screen lower left, in quotes, semicolon. So you see that? Lower right, lower left. Here's the controls. Okay, cool. And maybe I'll just make this hit home a little better by throwing that on there. Okay, so this is the effect we're making. Alright, so we can control these interactively. And just as a point out to you type thing here. See how it's updating on that color down there in that corner? So yeah, literally that's what we're doing right now. Okay? So very cool. Very cool indeed. Okay. But we need to knock out the lower left side right now. So string UI name equals, in quotes, screen lower left here, close quotes, semicolon. String UI widget equals, in quotes, color, close quotes, semicolon. And then close greater than sign equals curly brace 1.0 f, comma, 1.0 f, comma, 1.0 here, close curly brace, semicolon. Should give you yellow. Yeah, because combination of red and green, I think, is yellow, if I'm not mistaken. Maybe. I have to think about that. Yeah. No, red and yellow gives you orange, so that wouldn't be it. It'd be yellow and blue gives you green, I believe it is, so there'd be, so this is some other color. This wouldn't be yellow. Sorry, yellow would be this one is 1.0 and then this one is 1.0, I believe, if I'm not mistaken. This one and this one as 1.0 would give you purple. Okay, anyways. Float 3 here, screen upper right. Sorry, I was just thinking back to my color wheel. Float 3 here, screen upper right. Open less than sign here, string UI name equals, in quotes, screen space upper space right, close quotes, semicolon here. String UI widget equals, in quotes, color, close quotes, semicolon. Close greater than sign equals, in curly brace, 0.0f, comma, 0.0f, comma, 1.0f, close curly brace, semicolon. Float 3 here, screen upper left. Open less than sign here, string UI name equals, in quotes, screen upper left, close quotes, semicolon. String UI widget equals, in quotes, color, close quotes, semicolon. Closing greater than sign equals, in curly brace here, 0.0f, comma, 1.0f, comma, 0.0f, close curly brace, semicolon. Float background depth here, open less than sign here, string UI widget equals, in quotes, none, close quotes, semicolon, closing greater than sign equals 1.0, semicolon. Okay, so now we have all four corners of our, now remember, like I said, this is an actual quad here. And so basically what we're doing is we're colorizing each point here of the quad, and we're blending its values across the UV space, across that quad. So as we go from here to here, we're blending between red and green. So it makes sense. So that's why we're getting this crazy cool, trippy variations in colors. And this is gradients, and they're really important to artists. That's what they use in order to make their controls look really cool on interfaces, and just it's used on a bunch of stuff. Anytime you want to make something look really classy, like those Apple glassy like interfaces and stuff like that, man, gradients, they just really make things look beautiful. They're also useful for a ton of other things too. So even for like if you want to do something like depth of field or screen space, or I mean, just man, they're useful for a lot of stuff, a whole lot of stuff. So I would definitely recommend checking them out as far as that goes, because they're really useful, very, very useful. Okay. So struct VSN here, open curly brace here, float 3 space position, colon position, semicolon, float 4 space UV space colon here, text chord 0, semicolon, close curly brace, semicolon. Struct VS out, open curly brace here, float 4 position, colon position, semicolon, float 2 UV colon text chord 0 semicolon, close curly brace semicolon here, struct FS out here. So again, we have to have the UV space. Now, even though we don't have an image in here, so you notice that we don't have the textures in here. So you can go ahead and delete those textures that we had over in the other one, because we don't need them. We're just going to take just the UV space here. That's all we need. And then we're going to manipulate and set our own colors in the UV space to colorize this. Basically, we're creating our own texture in real time and computing it on the fly as it runs. So literally, that's how we're doing this gradient and such. So literally, you're learning how to basically generate textures with this stuff. Okay, so struct FS out, curly brace here, float 4 space color, colon color, semicolon, close curly brace, semicolon. Okay, and then we're going to go ahead and hop on to our Vertex Shader. Again, our Vertex Shader is going to deal with our screen space aligned quad here that's going to fit to the screen. When I say quad, I mean a 4-point polygon that geometry wise it just fits straight to the screen. So that's what we're doing, and we're rendering again to this before we render our teapot. And again, because why, it's a pre-processed one, it's rendering to the scene, which means it's going to the screen, and so it's this is what's happening here. Okay, so anyways, VS out here, main VS, open parentheses, VS in, space, IN, close parentheses, open curly brace here, VS out, semicolon, out dot position equals float 4, open parentheses, IN dot position, dot XYZ 1.0, parentheses, semicolon, okay? And then out dot UV equals IN dot UV dot XY, semicolon. So here what we're doing, we're passing the position points of our quad and our UVs out of the vertex so that they're set up on our actual geometry, so that way we can paint them over here in our pixel shader. So close curly brace here, and let's get to painting. So we're going to real-time paint this thing based on linear interpolation. So we'll get into that in just a second. Now, you've already learned LERP. We're going to use it in a new way that you haven't used it yet. Now you can also do this on the models too, mind you, not just on the screen. You could actually make this teapot go all different colors based on the points on it around the actual UVs on the surface. We may do one of those later on. Not right now, further down the road. They're not as important, but they can be very useful, especially for debugging, hunting down problems and things like that. They can be really useful for that too. Again, they're also really useful for generating gradients, which again, artists use like crazy on interfaces and a whole bunch of other stuff, for doing like button controls, and they could use it in their art stuff too, easily, in order to make, really just helps punch things up and make them look wonderful and look amazing. It makes a big difference on it. Artists love to use it, also especially with like grass or anything like that, where you want to change and vary stuff over different iterations of points and stuff like that for mass instancing. Also useful for instance objects, where you sit there and want a whole bunch of different colorations and variations into the actual models, so not everything looks identical and the same. Just a whole lot of stuff you can do with gradients, a whole lot of stuff. So never underestimate them. They're very important to artists. Really, really useful. So FS out here, main PS here, and again FS or fragment shader, and main PS. The PS is for pixel shader here. Open parentheses VS out space IN, close parentheses, open curly brace, FS out space out, semicolon, float 3 here, bottom equals LERP, open parentheses, screen lower left, comma, screen lower right, comma, in.uv.x, close parentheses, semicolon. Okay, what's happening? We're doing a linear interpolation across the x-axis. Here across, well, U. X here would be referring to U in the UV space. Or if we were talking about S and T, it'd be talking about S for the one that's actually could be manipulated. But we don't actually have a sampler here, so we're directly applying the color to the UV's coordinates. So in this case, in.uv.x here, and x is going to be like going across, probably. Most likely, assuming that the orientation is matching with the UVs, like it should, but it doesn't necessarily. I mean, you could have the problem where it's going like this instead, because U and V can get swapped, and if they get swapped, instead of going across, for you it can go up vertical. So this depends on how the programmer laid out the UVs. In our case, the UVs should be going across the bottom here. And they are. Yeah, cool. So across X, they're going across the bottom, like I was hoping for U. So U is your X and V is your Y. Okay, so screen lower left here, screen lower right. So we're going from left to right, compute our color variations between them, between those 2 points. And since this is the far point here and this is that far point there, we're going to get every color variation between red and green. Since it's set to red and green, or whatever color we set it to, it'll do all the color variations between those two colors. And that's what's happening right here. So that's what the linear interpolation does. It does this blend value, does the linear interpolation, does a gradient, if you will, if you want to call it that, between these 2 points here across all the points on the, all the pixels across that quad for all of them in that UV space, which is the entire screen. So the entire UV space for that matter. Well, across X anyways. Now we need to do top. So now we need to do what? The top portion across like this, right? So we're going to do our screen upper left here, which is our blue one, upper left. And we're going to do our upper right one, so that purple one there. And we're going to blend across that with a linear interpolation. Great. So now we have this wonderful gradient that goes from here to here, going from blue to this purple. And we also have our other one on this other line for our bottom here, right? Because we did it right here. It's also going across X from our red to green here. So very cool indeed. Okay, now we just need to blend the 2 of them. So we need to have the colors going from, they're going from here to here for that blend, and the color variation from here to here going from that blend, and blend them together across this distance here, which is going across our UVs going in the Y direction. So how do we do that? Well, it's really not that difficult. We're just going to take a result of our blend for our bottom and a result for our blend for our top, and we're going to blend between those 2 now. So we're going to say going from bottom to top, blend them together, and we're going to do it across the UV space going in Y. And why do we do bottom to top? Because remember 0, 0, 1, 1, so we need to go from bottom to top. So that's why we're going to order it that way. So bottom to top here, and we're blending it together. Now we get these color variations of them all getting blended together like this for this gradient. Ta-da, there you go. So that's how we basically did the mathematics for this color gradient here in this background of this image here. Very, very cool. Once we're done with that, for our top bottom here, well, it's really simple. I mean, honestly, we could have just taken this color out and assigned it right here and did a float 1.0 on this thing instead of doing this as a separate calculation. That really wasn't needed on this one. So if you want to optimize it a little bit, simply just ditch this one here and then throw it up here and combine all that, because it won't take anything to do that. For your LARP, just add the float 4 with the 1.0 on it. But essentially that's what we're doing. We're taking our final result right here. We're adding our 1.0 for our alpha and setting it to color, because it needs to be a float 4 for color. Right now it's just a float 3 right here. So we're making a float 4 and we're returning out for the color. It should be pretty straightforward at this process here. That's how you can do a gradient. Okay. So technique here, 0 here, open less than sign here, string script equals, well, this whole fun grouping here, which is clear set depth equals background depth here, semicolon, close quotes, open quotes, clear equals depth, semicolon, close quotes, open quotes, pass equals PO, close semicolon, close quotes, here, and then open script external scene here, semicolon, close quotes, and don't forget the semicolon, because remember that's the end of this whole line. And I can just see people doing that. That'd be an easy one to mess up. Okay, so close greater than sign, open curly brace here, pass P0 here, open less than sign here, string script equals draw in quotes here equals buffer semicolon close quotes semicolon. Now remember, buffer is going to go to our double buffering, because you would never do single buffering, because then you would render the actual pixels to the screen as you're computing them, which cause all kinds of ugly artifacts, cause all kinds of ugly flickering. Have you ever seen that before from other programmers doing that? I've seen other programmers do this before. It looks nasty. Double buffering is how you get around it. By minimum, basic programming and graphics, you should be doing double buffering. You will learn how to do that in another series that we have, and we will never do single buffering. We won't touch it with a 10-foot pole because it is the nastiest, worst way to do it. So yeah, don't ever do that. Close greater than sign. Open curly brace here. Pass P0 here. Open less than sign here. String script equals. I already did this. I'm sorry. Open curly brace for this one. And then depth test enable equals false semicolon. Depth mask equals false semicolon. Blend enable equals false semicolon. See col face enable equals false semicolon. Def func equals L equals semicolon, same as before. Vertex program equals compile ARB VP1 and then main VS here, open close parentheses semicolon. Fragment program equals compile ARB FP1 main PS open close parentheses semicolon close curly brace in that function. So again, this runs on old hardware, really old hardware, as you can see, all the way back to fixed function pipeline. It'll run on everything. So very cool, very powerful, extremely useful to artists, and lets you create a trippy background. I'm going to go ahead and pull that off now because I want to talk about another screen space method. Oh, sorry, I really do want to actually indent that, please, without losing it. Okay, there we are. Very cool. Now, the next one we're going to look at is not a gradient, but is going to be our Skybox instead, which I think will make a lot of people very happy. There's our pre-color. Hold on a second. There's our Skybox. Alright, and why does our Skybox matter? It's this one right here. We're going to do it now. Now, I kind of showed it off a little bit earlier, but one of the samples came with the shader library, and if you remember, shader library has a lot of samples in it. The problem with the shader library, it wasn't meant for people to really learn from it so much. So things aren't necessarily written out in the easiest to read setup, and it's got a lot of stuff that's not required for an effect, a lot of extra extraneous stuff. This didn't matter. A lot of times, a lot of stuff doesn't even have anything to do with the effect. Some of the naming doesn't make any sense. Sometimes the comments aren't that great. Sometimes they are. It just varies. But yeah, definitely something to check out. You'll find a lot of great shader library stuff. But hopefully, after you're done with the series, the shader library should make a lot of sense to you, because we're trying to mimic close to that as possible, but keep things clean and straightforward as much as possible. So when you look over one of these techniques, it'll be easy for you to pick up and follow it, because we're trying to get it as close as we can, but keep it simple and easy to follow as you can with what's available in these shader techniques. So we're going to do a number of these shader techniques from this library, but recoded to where they're easy to understand and learn and well commented and good naming and stuff like that. So, you know, should make a big difference for you. Okay, so what we have? We have this, where we can look around in every direction here, and it's really cool, and it's like you're in the building. And this is commonly referred to as skyboxes inside of a game engine. And we're just going to get this set up because it does make a major difference. It makes things look very realistic that would otherwise not look nearly as realistic. Very good for like putting what's called skyboxes in there, where you have background skies that looks like it goes on forever in the horizon instead of just gray in your background. So yeah, sky is really nice to have instead of a gray blob in your background, just solid gray. That's what we had before, right? Now we're doing these screen space shaders, and check it out. Now we can do some cool stuff like this. I'm sorry, this is a pre-technique also. I'm not thinking this isn't a post technique. We'll get into post in the next video, not in this video. But in this video, we'll continue to do the pre-process on this. So float here script colon standards global as always. Here, opening less than sign here, string space UI widget equals in quotes none close quotes semicolon string script class here equals in quotes scene close quotes semicolon, because it's going to the scene again, which means it's going to what? Our screen. Yep. And then string here script order equals pre-process. Why? Because we're going to compute this before we actually start rendering our models. And then string here script output equals in quotes color close quotes semicolon, because we're going to do color. That's what we're going to output. And then which technique are we going to execute to make this happen? Well, that's going to be our technique equals technique 0 semicolon in quotes semicolon, and closing greater than sign equals 0.8 semicolon. Now what you probably want to do when you're setting this one up is go over here to create effect, CGFX, select empty, and to say ScreenSpaceGradientSkyBox CGFX, pop it in there, and say good to go. And then just copy your one for your texture background pre-processing texture one that we did in the first video, and copy and paste that into this one here, because we're just going to reuse that one again too. Just like we reused it for the gradient we just did, we're going to reuse it also for this one here. And yeah, don't reuse your gradient one, use the texture one, because that's a closer match to what we're going to do here. Okay, so with that, we're going to do a float 4x4 world view IXF colon, which is a world view inverse. So make sure you have this one. We're not doing the projection one, we're doing a world view inverse instead. It's more robust for what we're doing in this case. So open less than sign here, string UI widget equals none in quotes, close quotes, semicolon, close greater than sign, semicolon. And then we're going to do float background depth here, open greater less than sign, string UI widget equals in quotes none, close quotes, semicolon, close greater than sign equals 1.0 semicolon. Again, we're doing that background depth, and it's going to be set to 1.0. Alright. Now all this stuff should be the same, except for this right here. This is different than your world view projection matrix, because instead we are doing a world view inverse matrix. This is the reason for the world view IX. I is for inverse matrix. Okay, so now we're doing our textures here, and we've changed something. Okay, so it says texture here, and then we're going to call it Skybox texture, and then open less than sign here, string resource name equals in quotes default underscore reflection dot DDS close quotes semicolon. Now this one matters. This is the same one you had from when you were doing your reflections one before for your cube map, and it needs to match up with this, because if it doesn't, you're going to have a problem. You're going to have a big problem. Okay, so this is not the standard texture we were using earlier. This is the reflection texture. Make sure you put that one in. This has to be a cube map in order for it to map in 3D. String UI name equals in quotes here Skybox texture close quotes semicolon, string resource type equals in quotes cube close quotes semicolon, closing greater than sign semicolon, sampler cube Skybox sampler equals sampler underscore state, open curly brace here texture equals less than sign Skybox texture close greater than sign semicolon here. Then min filter equals linear bitmap linear semicolon, mag filter equals linear semicolon, wrap s equals clamp to edge semicolon. This is important. Wrap t is equal to clamp to edge semicolon. Again, important. Wrap r equals clamp to edge semicolon. Yes, it must be like that. It's got to be clamped to edge. Okay, it's important. Okay, so with that, let's move on down. Now, these texture coordinates are different than what you've used to being seen previously. This is, okay, let me put it this way. It's different than what you've seen so far. What we're going to do is what we should have been actually doing before, but we were able to get away with it, and it worked anyways inside of FX Composer. I don't know if it necessarily get away with it in an actual application. I haven't tried it yet, implementing it in an application with these coordinates. So, well, I take that back. I think I did, but I can't remember anymore because it's like a year ago. Anyways, I did do it actually, but I can't remember what I did now. I'd have to go back and look again. but in and out parameters here, and for our quotes, for our comments, and then we have our struct vs in, open curly brace here, float 3, position, colon, position, semicolon, and then we have float 3 here, UVW. Now W is typical. This is the naming for this. It's UVW, colon, text coord 0, semicolon. And it's a standard. Most artists are familiar with this, but this is your 3D coordinate system. This is not a 2D coordinate system. We're only doing 2D coordinates of like X and Y, basically U and V, that you just put in UV here. But when you're doing X, Y, Z coordinates for 3D texturing, then you need UVW. The W is going to be your Z axis. Close curly brace semicolon for this. Okay, so and again, we're going to have to continue with this UVW part. So what are we doing here? We're passing in the position of the vertices on our box here, not our box, but I'm sorry, our quad here, and then we're also passing in our 3D coordinates for our plane here. And well, basically our UV coordinates are going to be manipulated here on the actual object for our image to map it to this plane. So it's an actual 3D lookup, so that way when we're angling this different ways or whatever, it's based on the view. And so yeah, the view is basically what we're doing to look up the pixel. But when we angle our view here, it's actually looking it up accordingly from there. And that's what's happening, essentially. Okay. So struct vs out here, open curly brace here, float 4 here, position, colon, position, semicolon, float 3, UVW, colon, text coord 0, semicolon. And yeah, so this is world coordinates. So there we go. Close curly brace semicolon, struct fs out, open curly brace here, float 4, color, colon, color, semicolon, close curly brace semicolon. So of course we have to output color because that's what we said we're going to do up here earlier. See, we're told that we're going to give it color, and that's what it always is for pixel shader anyways, because that's the only thing you do in a pixel shader is color. So hey, it's going to have to be color. So it makes sense that's what we're going to process. Okay. With that, we're going to say Vertex Shader. Okay, so we're going to do VS out here, space main VS, open parentheses, VS in, space capital IN, close parentheses, open curly brace here, VS out, and then out, semicolon here, for our all caps out here, and out dot position equals float 4, open parentheses, IN dot position dot XYZ, and then comma 1, close parentheses, semicolon, and this is our out position, yep, being passed through. And then out.uvw equals to mul here for multiply, open parentheses, world view IXF, comma, float 4, open parentheses, negative IN dot position dot XY, comma, 1, comma, 0, close parentheses dot XY, Z, semicolon. Okay, what was that? Okay, mind you, what did I say? We're mapping to a plane, right? Okay, let's keep that in mind. So we have our world view inverse transpose. Not transpose, sorry. World view inverse matrix. Okay, and we're multiplying that times our negative opposite of our position. But this is only in the position for X and Y. Okay, so we're only looking at what? These coordinates here. And then we're just going to give it the default value of 10 for Z, which is quite standard actually. Either do a 10 or you do a 0. In this case we're doing a 10. And then we just need for the fourth value in order to multiply our matrices together a 0. So, you know, we're just going to put a 0 in there just because we need a value there. So 0 makes sense to put that there. So that's going to let us, you know, fill out the rest of this so we can do our multiplication here. And then we're just going to return, we're not going to return whatever value we get with the 0. We don't care. We're only going to return the X, Y, Z, which matches up because we only have 3 values here that this can accept for a vector that has, you know, 3 floats. So because of that, you know, we're going to be passing in X, Y, Z over here. It can't handle X, Y, Z, W, you know. So for that matter, we're only passing back 3 values after we do this calculation with 4 values. Okay, so there we go. We get our position now for our vector happening here, which we're going to use for a point lookup, and we used it actually to do the point lookup. And remember, it's going to multiply this times -1, flip her back around afterwards for this vector, so it's going in the right direction for looking at the pixel here, and we return the out for that color. So it grabs that color lookup value, and now we have it matching up for the, sorry, not color lookup value, my mistake. So that way our vector is now facing the right direction. My mistake, I'm sorry. The vector would be going towards the actual pixels, where it should go anyways, for that point on the surface. Okay. Again, this is the actual plane here, ScreenSpace quad here, that we're doing our calculations for in order to do our lookup. And so yes, that's for the UVs. And that is for looking up the pixel point, but we haven't gotten to actually sampling the pixel because we need to do that down here. But yes, like I said, this is getting us the vector to look up the pixel, and that calculation was done here. Okay. Down here in our FS out main PS, I'm sorry if this is confusing, open parentheses VS out here space IN in caps, close parentheses, open curly brace, FS out space out semicolon here, out dot color equals text cube here, open parentheses, Skybox sampler, comma, in.uvw, close parentheses, semicolon. It makes sense to do your calculation for your lookup value over here because it's not going to change. So it would just be extra computations to do it over here in the pixel shader. So if you do it over here in the Vertex shader, it's faster, basically. So that's what's happening. We're calculating those vectors to look up these pixels. So now that we got the magical vector from over here in the Vertex shader, we just simply pass that into our Skybox sampler, and it grabs the pixel that we're looking for based on that vector. So now we have our vector facing in the correct direction from our quad here, and it's going to point to the right pixel. Alright, so return out right there, close curly brace here, technique space technique 0, opening less than sign here, string script equals here, in quotes, clear set depth equals background depth, semicolon quotes, open quotes, clear equals depth, semicolon quotes, open quotes pass equals P0, semicolon quotes, open quotes script external equals scene, semicolon close quotes, close semicolon, close less than sign, because again we're doing what? We're going to the scene, which is going to go to the screen. And over here we have clear set depth here is going to go to our background depth that's being set for that. Remember that was 10, so that's what we're setting our depth for. Clear the depth afterwards, we don't need any more. Past 0 here is going to be this one over here, and that's what we're going to use for this technique. Okay, so open curly brace here for our technique. We're going to do pass P0 here, open less than sign, string script equals, in quotes, draw equals buffer, semicolon, close quotes, semicolon. And again, we're drawing to the buffer for the double buffering for the rendering of the graphics, because we're putting this on the background here before we're rendering the object. So this gets rendered out in this particular frame of animation here before our actual objects get rendered out. Okay, open curly brace here. Depth test enable equals false semicolon. Depth mask equals false semicolon. Blend enable equals false semicolon. Cull face enable equals false semicolon. Def func equals L equals semicolon. Vertex program equals compile ARB VP1 main VS open close parentheses semicolon. Fragment program equals compile ARB FP1 main PS close open close parentheses semicolon close curly brace, and that's the end of that shader. So this again is the ARB VP1. That is our fixed function pipeline, so this is as old as it gets on the hardware, so this will run on basically anything. So very cool, and this should run on anything you can imagine, even the oldest computers, hardware, whatever. Don't forget, you can go all the way back, ancient hardware, and it'll still work with this. So this really works on a lot of things. Okay, with that covers how to do this Skybox. I'm just going to careful about what I click here. Save that. I'll click over here. If middle click, I'm middle clicking over here. Then if I do Control Z here to undo, it removes that shader here. And hopefully it doesn't remove any other stuff you're typing. If it does, again, don't forget you go here to Edit, Redo, in order to make it redo something you already did, and in order to get back the shader. So that way you don't lose it. But with that, that covers this part, screen space. In the next video, we're going to step it up some. We're going to start doing post effects, and we're going to start doing, oh gosh, what else? We're going to do pass-through. This is pass-through. We do it on the object here, like so. We're going to do pass-through in the very next one. Okay. Besides that one, we're going to then step into doing Radial Blur, I think. That's the one I want to go with. Yeah, I think so. Yeah, it's time to do Radial Blur in the next one. Let's do Radial Blur. So in the next one, we'll do also Radial Blur. And you're like going, oh, what's the big deal? No, dude, check it out. This is Radial Blur. See, we're going to do that in the next video. Okay? Very cool. So feel free to check that out in the next video, and hopefully you enjoyed this whole thing on the Skybox. It's a very important technique and very important thing you need to know. And well, all this stuff, and you learn gradients too, which is really cool and very useful. All right, so with that. That was screen space shading, CG shading series here for the whole gradients and for pre-color, pre-processing, and for the cube mapping for Skybox. With that, my name is Nate Nestler, and this is for Hyperactive Studios. Thank you very much.